All right, so one of the first people to propose that and study that the continents moved apart, or what he called continental drift, was a guy named Alfred Wegener. Right? Alfred Wegener was a German meteorologist. He was an explorer. He went to the poles, Antarctica. Notice he only lived for 50 years. He died actually very young. He was on an expedition to Greenland when he died. I'm not going to show you the video, but there's a really good video. Alfred Wegener, Great Minds. It's only less than 5 minutes long. If you're interested, it talks a lot about him, what he was studying and what he did and that kind of thing. I'm not gonna play the video, but if you pull it up, it's a really good video to watch if you're interested. But anyway, Wegener proposed that 250 million years ago, all the continents were connected, and he named it Pangaea, which is a word that means all lands. Now, why did he make this proposal? Well, he made this proposal because he was one of the first people to notice this. All right, he noticed that specifically to start with, he noticed that South America and Africa kind of sort of fit together like a little jigsaw puzzle. And that got him thinking that I wonder if they were together. Were they together? And that got him going. That got him thinking about it, got him studying this. All right? And once he started studying all of this, he started coming up with other evidences to support it. Right? So we have a lot of evidences now to support this theory of Pangaea. Right? Unfortunately, Wegener died before he was able to finish his research and before he was able to figure out the mechanism for why this happened. We know now why it happens, right? But he knew it happened, but he didn't have the reasoning. He couldn't figure out how it happened or why it happened, unfortunately. But so first evidence we have is the coastlines. If you manipulate them around, you can kind of sort of get them to fit. And again, you have to remember that the oceans were lower back then, so it's really the continental shelves that fit together really well, not necessarily the modern coastlines. But. All right, we also have some fossil clues. We found the fossils of several freshwater reptiles and a bunch of ferns and things like that. We found fossils of these things on multiple continents. Conceivably, the animals probably could have swum across, but we've studied the anatomies and we've concluded that they're, again, freshwater and that their limbs would probably not have allowed them to swim those great distances across ocean basins. Okay? We can kind of see, if we take where we found those fossils, we can manipulate the continents around and they match up. We can get them to match up quite nicely across multiple continents. We have since found clues in the rocks. All right? If you look at the Appalachian Mountains in the United States, they are very, very geologically similar to the Caledonian Mountains in Greenland and Europe. Essentially, they were one mountain range that split apart when the continents separated. Right? They formed together as one mountain range, and then they split apart. We found some clues in the climate. Right? We found coal deposits in cold climates. Now, coal, we know, forms in tropical climates because it forms from the decay and breakdown and compaction of dead tropical plants. But we found coal, we've been able to mine coal in areas of North America where it's colder, and we know it's not tropical, so that tells us that probably where we are right now would have been over the equator at some point. It would have been tropical. Would have been a rainforest area, tropical rainforest area. And we can see that the coal mines, European and North American coal mines, all line up very nicely. These are the Pangaean coal deposits in that gray band, and they match up nicely with the continents. We find coral limestone in New York State. Now, in order to have coral limestone, you had to have coral, and coral grows in warm tropical oceans. New York State at one time must have been covered with a warm tropical ocean, and that it has since drifted northward away from the equator to its current location. Glacial activity, we find. If you look in that little inset map in the upper right, we see evidence of glacial scratches in the bedrock. So what I mean by that is as a glacier forms and it starts to flow downhill, it picks up rocks and it drags them along and it digs into the bedrock and it makes scratches in the bedrock. And we can see that those scratches, if we bring the southern continents back together, they match up and create one giant ice sheet that once covered all those continents had they been together. All right. You can kind of see here where we find all those different evidences. We can see on the different modern continents, and then we can manipulate it down here in the bottom right to create that Pangaea, where we can find a lot of that, a lot of the southern continents with the fossils. We got the coal, all right, coal beds that match up nicely. So we've been able to recreate kind of what he was working on back in the early 1900s. Now, real quick, if we were to take and look at those things individually, okay, for example, let's say I make an observation, we'll call it observation X. I might be able to explain it, and let's say I can explain it in 3 different ways, okay? So I have 3 explanations. I'm not exactly sure which one is correct. They all are potentially okay. Let's say I make another observation. We'll call it Y. Maybe I've got, I don't know, 2 or 3 or 4 explanations to that one. And then I make another observation. And let's say I've got some explanations for that. What do you see happening here? If I just look at one thing, I make an observation, yeah, I can explain it in multiple different ways, so I don't know what's the correct explanation. But when I start adding more observations and adding more observations, even though individually they might only have, you might have multiple explanations, if they have a common explanation that fits all of the observations, that tells me that that common explanation has probably got to be the correct one. It's the only one that explains everything that I see going on in nature. And that's what's going on here, all right? Taken individually, those little things I've been talking about might not mean a whole lot. But when you put the shape of the continents, and you put fossils, animal and plant fossils that match up, and you put mountain ranges matching up, and rocks having similar composition on different continents matching up, similar ages, and we look at coal deposits we can find in different locations, and we find limestone where we shouldn't find it, coal where we shouldn't find it. By themselves, it's not compelling evidence to support that theory. But when you look at all of it together, the only explanation for all of it that fits everything is that the continents were once together and have drifted apart over millions of years. That's the only thing we can come up with. All right? And so that's what we work with. That's how science works. We don't prove things in science. We have a hypothesis, and then we look for evidence that supports it. If we find evidence, we continue to look and research and peer review and all that until or if we find something that refutes it. And if we find something that refutes it, we go back to the beginning and start over. But if we don't find anything to refute it and we just continue to find evidence that supports it, then that's going to be our working explanation. That's the one we're going to go with, and that's the one that we accept. That's how science works. I forgot about glaciation. Sorry about that. Okay. All right, here's a little modern reconstruction of Pangaea. The one on the bottom is, we pulled it from a book that he published in 1915. This is what he thought was going on. But more evidence, more research has given us kind of a better idea of what we think happened. We think actually Asia was separate. It wasn't the giant one continent it is today, that it was, the motion has caused the Southeast Asian continent and the Asian continent to come together. But we've kind of created a modern reconstruction of what we think was going on at the time.